Okay, so this is going to go super duper quick. This is the first of two videos. This is 9.1, 9.2, 9.4. So sequences and patterns, specifically arithmetic sequences and series. So here we go. First things first. 9.1 is all about patterns, patterns, patterns. Notice them, use them, maybe even find the recursive formula. What is the recursive formula, you ask? It's a sub n equals a sub n minus 1 plus some pattern. And so if you see minus 1 could give you the answer. You're looking for a sub n minus 1 because that means it's the previous term. So that being said, the general method to solve some of these is, let's say you're given a sequence of numbers, 0, 3, 7, 12, and 18. And so you look at this, and the first thing you're going to see is you're going to try to see if you can see a pattern. And in this case, you can see it goes up by 3, then up by 4, then up by 5, then up by 6. So plus 3, 4, 5, and 6. So then you're going to say, is it arithmetic? Is it geometric? Or is it just some sort of pattern? So if all these numbers are the same, then it would be an arithmetic series, adding by the same number every time. If all these numbers are the same and it's multiplication or division, then it would be geometric. In this case, these numbers aren't all the same, so it's neither. So you're not going to use any of your flower pot formulas here. You're just going to see the pattern, apply the pattern, and find some number of terms. So for example, in this one, we know the next thing we're going to do is add 7. And so if we do that, we know our next term has to be 25. And so you can keep doing that if they ask for the 8th, the 9th, the 10th, the 11th. The only problem would be is, let's say they want to know like the 20th term. Then you're going to have to find either the explicit formula or a recursive formula. And I'm here to tell you that they're not going to ask for an explicit formula here. You may have to find it in a table, but you don't have to deduce it yourself. They're always going to ask for a small number of terms like 10. And so you can see this is 1, 2, 3, 4, 5, 6. So you'd have to find the 7th, the 8th, the 9th, and the 10th. And so 25 plus 8 now would be 33, plus 9, 42, plus 10, 52, plus 11, 63. And you have just done everything I expect you to do from 9.1. Bam. Sometimes you might be asked to write the explicit formula here, and like for example, the recursive formula, and for here it's not abundantly clear. I'm telling you it will only be abundantly clear if it is like an arithmetic sequence and it's asking you to write the recursive formula. So let me give you an example of that. So you can see that it's going up by 1 each time. And so we could use a flower pot formula here, but for the sake of showing you, I want to know the recursive formula. See how we're going up by 1 every time? You can see that for any number of term, so let's say any number of term, it is simply the previous term plus 1. And that is a recursive formula. So you could see if I wanted to know the 7th term, I would have to first find the 6th term, and then now I could say a of 7 equals a of 7 minus 1, which is the 6th term, plus 1, telling me the next term in my sequence is 7. So that's basically it for 9.1. Let's move on to 9.2. Oh man, what did I do? Oh man. I just wanted an arrow. Okay, so for 9.2 and 9.4 is arithmetic sequences and series. And so this right here, big time example of that. It's going up by the same thing every time. Up by 1, up by 1, up by 1, up by 1, or down by 1, down by 1, down by 1. So the general rule of thumb, if you have a sequence that is plus or minus the same, and let's say I want to know the, let's be cool, 32nd term. Well, it's that easy. You can see it goes up by 3 terms. pause and play. So hopefully while you were gone, you could see that you had to do this. A to the 32nd